off and say good evening to everyone and welcome to Fires, Floods, and Flagstaff. I'm Sherry Schaefer. I am a Flagstaff Festival of Science board member. My co-host is fellow board member Jacqueline Salabai. And before we get fully started, I've got a few housekeeping items that I need to share. First off, all questions need to be put in the Q&A box. Everyone's going to see the question and you'll be able to upvote any questions that have already been asked. Jacqueline's going to moderate the Q&A at the end of the talk, so put them in at any time, upvote the questions you think you really want to hear about, and we'll address those at the end of the talk. The chat box, it should be only if you have any technical issues, that kind of thing. No one else is going to see those. Only the moderators are going to see that. If you haven't already, please download our new app. And Jacqueline, if you would put the links to the Apple and the Android stores in the chat, that would be great. It is a wonderful way to see our schedule, sign up for events, access past video content, find information on the speakers and the links to their events. There's also a fun scavenger hunt with attendance badges, and there's a fun photo filter. For those of you who are doing the scavenger hunt and collecting attendance badges, the validation code is Mazursky. So Jacqueline, if you put Mazursky in the chat, that would also be great. You can also find the full schedule on our website at scifest.org. Many events don't require any registration like you did for this one, but for those that do, you can find them on the app and on the website and on our Eventbrite page. Again, Jacqueline, if you would put that in there for them, that'd be great. There are two ways you can help us out with the festival. First, every single festival event is free, and we always need donations to keep it that way. You can easily give through our website or the app. Second, we have a survey that we use to help make your experience better and better each year. Jacqueline's going to put that link in the chat, and we're also going to put that in at the end of the program. So now, without further ado, I'd like to introduce our featured speaker for Fires, Floods, and Flagstaff. Our speaker this evening is Brian Klimowski. Brian has served as the meteorologist in charge of the National Weather Service Forecast Office here in Flagstaff since 2003. He currently serves on the board of the Flagstaff Festival of Science and has been researching the climate change signals of the local area for several years. Brian is a weather nerd, outdoor enthusiast, and a photographer wannabe when otherwise not distracted by clouds. So thank you so much for joining us tonight, Brian. Please take it away.
All right, let me go ahead and share my screen here that everybody should be able to see. Give me a thumbs up, Sherry. Let me know that you can see that just fine. All right, well, let's go ahead and get started. Thank you very much for having me here today. I really appreciate it. It's been quite a year for us. It's been sobering as far as the amount of impacts that we've had from the fire and the floods, and just the amount of high impact weather in 2022. These are the things we're going to be talking about today, digging a little bit into the science behind what's happened and just doing an overall review of the year that we've had. So like I said, it's been a tough year for us here in Flagstaff. We've had 3 major fires, then a very active monsoon with a lot of impacts, flooding impacts. You know, I'm sure we all know people who saw either damage from the fires or significant damage from the floods. We had hundreds of homes in many neighborhoods that have had serious damage from the mud that came down in the floods after the fires as well. And you know, every time around here we see smoke in the sky, it kind of sends a chill down our backs. Anyway, so what we're going to be covering today is a couple of things. First, we're going to talk about the fires of 2022. Why were they so severe? Why did they spread so rapidly? Then we're going to talk about the monsoon that we've had. And as a matter of fact, it's still with us. You know, we still have elements of the monsoon in place this late in September, which is actually pretty unusual. We'll be talking in a bit about that. And then the post-fire flooding we've had. here in the area. What's brought about the damaging floods? How unusual have these storms been that have brought about the storms that we have seen? So let's talk about what brought us to the fires that we had this spring. Well, it was a very dry winter and spring. What we're looking at here is an image that shows the percent of normal of the January precipitation. Where it's red, we're well below normal, only 10 to 25% of normal. You can see most of northern Arizona in the Flagstaff area here in the middle, well short of normal. If you go on into February, kind of the same story. We had a little bit of precipitation, but still well below normal, less than half the normal precipitation in February. Let's roll on into March. Looks like kind of a broken record. Much more of this picture is yellow, red, and orange than blue and green, which would show above normal precipitation for March. So again, March was pretty dry. In April, almost no precipitation at all fell in April. It was very dry. And what this did is it set the stage to have very dry fuels on the ground as we worked our way into April. So what I'm going to show you next is a graph. Okay, this is a graph of the fuel dryness, both the live and dead fuels combined, working its way from January 1st on the left through actually the current date on the far right. But I have two arrows there which show the dates of our two main fires, the tunnel fire on the left and the pipeline fire on the right. And what you're seeing there is the blue line is the relative dryness of all the fuels, as expressed in what's called the energy release component. Okay, the red line on top is as dry as the fuels have ever been in recorded history from 2003 to 2021. Okay, and as you can see, is as we worked our way through April near the first arrow, which is pointing down, the fuel dryness or the energy release component got almost to record dryness by mid-April. As we worked our way into May, indeed, the values we saw were as dry as they've ever been. And by the time of the pipeline fire, come early to mid-June, again, we were near record dryness for all the fuels. So the dry weather we had from January through mid-April set the stage for the fires that we then experienced. Let's talk about the fires. We had three main fires in northern Arizona in the Flagstaff area, consuming about 90 square miles were burned in these fires. They started in mid-April. On April 19th, the tunnel fire was started. This is very early for our fire season to start. Luckily, our monsoon started a bit early, which kind of ended the fire season in late June. But we had the pipeline fire, which then was ignited and started on June 12th. So April 19th, again on June 12th, two rapidly spreading wildfires that spread on very strong southwesterly winds that blew the fires to the northeast. The Haywire fire started shortly after the pipeline fire. Really didn't see many impacts from the Haywire fire, so we're not really going to be talking about that one. But let's talk about the weather conditions on April 19th and June 12th. They share a lot of similarities. Both these days that the fire started and grew so rapidly were very dry and very windy. What we would say would be red flag conditions. Relative humidities around 10% and winds gusting, say, from 30 to 50 miles an hour. We also saw some pretty impressive topographic effects of the winds. We saw downsloping, especially impacting the tunnel fire, which increased the winds even more. As we already talked about, the fuels in the forests were very dry. So the fire, which did start and was pushed by these strong winds, just burned right through extremely rapidly. I have two pictures here. The one on the top is of the first day of the pipeline fire. The second picture is the second day of the pipeline fire. And you can see those plumes of smoke just being pushed by very strong winds as the fire rapidly burned through the undergrowth. Okay, the tunnel fire wasn't, it was fascinating, the weather conditions that started during the tunnel fire, is the winds were actually pretty calm on the morning of April 19th, but there were very strong winds aloft, 50, 60, even 70-mile-an-hour winds, a couple thousand feet above the surface. And soon after sunrise on April 19th, those winds started to downslope off the peaks and impacted the fire site, where the fire rapidly spread through some very fine fuels, some dry grasses in an area that was burned about 12 years ago from the Schultz fire, rapidly burned through these very tall grasses into the timber, and then ended up burning over 30 homes on April 19th. I have a time lapse that shows downsloping winds that I'll be showing next. And what you're going to see here is on the left, you can see the skyline of the San Francisco peaks on the left. This is kind of an ultra wide angle picture. And you see these streaks these are actually smoke streaks from several years ago, but it demonstrates downsloping conditions. Here as the smoke and the winds are downsloping off the San Francisco peaks, down over the Donny Park area, they actually rise again in what's called a hydraulic jump on the right-hand side. So it's downsloping winds rising again, but you can see that this leads to very complex flow downstream of the San Francisco peaks, to where the winds can actually turn on themselves, turn backwards, swirl in many different ways. And that's exactly what we saw during these fires. What I have here is some pictures of the extreme fire behavior we saw during, in this case, the pipeline fire. On the bottom left is a horizontal roll. Some people would call it a Kelvin-Helmholtz wave of types. It looks like an ocean wave, to the winds are blowing at the low levels from left to right, then being turned on themselves and coming back over the top, back toward the left. On the right-hand side, in the larger picture, is what we call a fire whirl. It's basically a dust devil, but made of smoke. Okay, very strong circulation, anchored on the ground from the strong updrafts and the heated air, which is made visible by the smoke. Both of these types of conditions is evident of the very dangerous nature of the winds, the extreme fire behavior that happened during the fires that we saw this spring. All right, so fires promote flooding, okay? When the soil gets heated, to very high temperatures, we're talking over 200 degrees Celsius, over 300 degrees Celsius, the soil changes composition. Everything which is burned, whether it be the forest, the underbrush, the grasses, the roots, causes very large changes in the composition of the soil, which just changes it from conditions to where normally they could retain water, to where the soils actually become hydrophobic and it repels water. It doesn't allow it to soak in. Roots that would normally be anchoring the soil become burned and are no longer there to hold the soil in place. So rocks, soil, and debris can be pushed away off the slopes from the mountain after a fire when the soils have been burned. Rain quickly runs off, especially the steeper slopes, when it happens, and carries all this ash and debris with it. Many of us probably in the audience are very familiar with this. We've lived through the Schultz fire, we've lived through the museum fire, and now the pipeline and the tunnel fires, which again show these actions in place very dramatically. Okay, here's kind of a quick visual of indeed the pre-fire and the fire conditioning of the forest soils, to where before the fire, like I said, you have a very thick forest litter. This can be several inches thick, of those compressed pine needles, for instance, old branches, maybe grasses that have grown up, that do a very good job of holding water on the forest floor. This is the pre-fire conditions that we see in the San Francisco peaks. I've seen it rain 3 and 4 inches in just an hour or two up on the peaks, and have the forest litter just hold that moisture very well and not cause any flash flooding. But after a fire, what you'll frequently see is just an ash layer, this burned layer, where maybe even all of the forest litter has just been burned away, and a hydrophobic layer there, which if you pour water on it, it will just run right off. So what we see when heavy rain falls is that it can saturate this top layer of ash and dark soot, which is on top of the hydrophobic layer. And like it shows on the bottom here, it can just, these soil layers can just break off and be carried by the water downstream. And what I'm going to show a video here is the result of this. This is from July 14th in the government tank wash during the first major flash flood we had on the east side, as all that soil and debris was released from very heavy rains high on the mountain. It never rained down low on the mountain on this day, but it caused this debris flow to rush down the mountain on July 14th, working its way miles downstream. Over 6 miles it went before it reached the Doney Park area and flooded Pioneer Valley. It crossed and closed Highway 89. It took over an hour to get all the way from the top of the mountain and wind all the way down to cross Highway 89. People have asked, how fast do flash floods go? And a good estimate is about 6 miles an hour. And that is indeed about the pace that this flash flood was moving, carrying logs, carrying rocks, carrying everything in its path as it pushed farther and farther downstream with this black, sooty water, which then impacted the neighborhoods terribly on that day. So let's talk about the flooding, the origin of the flooding, and kind of forecasting for these flash floods. Here I have a map that shows the burn scars from the pipeline and the tunnel scars. A couple of landmarks here is Highway 89 off on the east side as it cuts through the fire scar up in northeast Flagstaff. Highway 180 is down here on the left. The fire scar kind of crosses, especially the pipeline fire scar, crosses the kind of crest of the peaks right here. So it splits between watersheds that flow toward the east and flow toward the west. There's 11, actually there's 11, not 9 drainages of concern on the east side and 2 on the west side. So it makes forecasting and modeling the impacts of these floods very troublesome. But the first thing to do is to very closely and very carefully diagnose and map where the watersheds are. Water that falls in these areas are going to flow through a watershed and down the base of it. It's very important that those are mapped extremely carefully when we're looking to forecast where the floods are going to be. But we also need to have a good idea of the burn severity. And the BEAR team, as we call it, the Burn Area Emergency Response Team, is the team that after the fire is burned out, goes up and assesses the burn severity. That is critical because the response of water and rain falling on the burn scar will depend strongly on just how severely those soils are burned. If it's severely burned soil, it will respond like I showed earlier. It will cause hydrophobic soils to form. The water will rush right off of it. If it's low intensity burn, the response is much less. So it's critical that we identify those areas of high burn severity when it comes to forecasting and modeling any subsequent flooding. We sent a team of meteorologists with the Forest Service to the pipeline burn scar to kind of evaluate the burn severity and kind of get our own eyes on. Here we are standing in one of the areas of high burn severity of the pipeline fire. And we saw a lot of features, but you can look at the ground in this area. where normally you might see 3 inches of thick pine needles and forest litter and bushes and small shrubs, you see absolutely nothing. The forest floor is completely denuded. Everything was burned up. You see holes in the ground where stumps used to be. So whole trees used to be in these areas, rooted where these holes are, but the stumps burned and were consumed over days, turning into ash and then just hollowing out. These stumps used to be. This is a great example of a high burn severity area. Okay, so the county has done a great job with their modeling of these complex drainages, working with J.E. Fuller and Associates that did the modeling. We were able to get a good idea, given certain rain thresholds, of where the water would flow based on the burn intensity. Here showing red where it's most burned. The watersheds are outlined in the thin blue lines. They were very quickly able to identify watersheds that would be of greatest risk for significant flooding. One that came to mind immediately was the government tank watershed up here in the upper Weatherford Basin, where the Weatherford Trail used to go. We could see that much of it was burned at a high burn intensity. And if you trace down this drainage, you can see how it works its way down the mountain, crosses 180 near the solar plant, and then would move just north of Caves Crater and work its way down into Pioneer Valley. I used to live down in Pioneer Valley, so I know this area very well. I know a lot of the people down in Pioneer Valley. And as soon as we saw these modeling results, well before any of the floods happened, we were very concerned about this neighborhood in Doney Park and the risks to flooding that would happen. But we also saw great risks in Timberline, near Campbell, Copeland. And what's not shown on this map are some watersheds up at Wapatki Trails that were under great risk as well. But the modeling was critical in our ability to identify those areas of greatest flood risk. And then the monsoon came, and we had an active monsoon. The Flagstaff office, one of our primary jobs is issuing flash flood warnings whenever we see those conditions that might lead to flash flooding in a particular area. We issued 330 this monsoon season, which is well above normal. Normal would be about 100 or so, with 95 severe thunderstorm warnings issued as well. Precipitation that fell this year so far, well, at least as of September 22nd, about 150% of normal. The graphic on the left shows purple, all those areas that are estimated to be about 150% of normal for the last 90 days, encapsulating most of the monsoon season. I have a couple specifics here on the graph. The Flagstaff Airport, as of the 22nd, had 10.6 inches, which is just behind last year when we had 10.7 inches at this time last year. But areas like the city of Prescott has had almost 14 inches of rain so far this year. So wet over most of northern Arizona, the monsoon of 2022. But what's really fascinating is the variability just around the Flagstaff area. So here I have a map with Flagstaff here kind of in the lower center of the image, the peaks up here near the top. You can see some very extreme variability in the rainfall amounts this monsoon season. From near downtown Flagstaff, which had a very normal monsoon of about 7.7 inches, which is right in that range of normal. But you don't have to go far. Just up here in Doney Park, the Timberline area had over twice that amount. Actually, the whole eastern part of Flagstaff saw well above values, over twice what you would normally see during the monsoon, with 14 inches up here at Sunset Crater National Monument. Like I said, 16 inches in Timberline. Walnut Canyon, 14.7 inches, almost 15 inches, over a foot of rain during the monsoon. Up in the peaks, couple of the areas, well over 15 inches. Here we have almost 18 inches in the inner basin at our gauge up there. The west side didn't see quite as much as the east side, and the airport came in, like I said, with 10.6. But this isn't all that atypical for there to be a wide range of rain amounts during the monsoon in a relatively small area. We can look at the monsoon in another way, and this is kind of fun. What we're doing is we're working our way from June 15th, which is the start of the monsoon, through September 30th on the right, and looking at the percent of Arizona with measurable rainfall. An average percent would be this black line near the bottom. So, during the peak of the monsoon, an average day we'll see 25% of Arizona with measurable rainfall. And you can see during this monsoon, we're well above that black line for the vast majority of the days of the monsoon. Just for fun, let's compare that to 2 years ago during the monsoon of 2020, and the graph looked like this. Very different picture in 2020 when Flagstaff recorded one of their driest monsoons of all time. All right, moving along. Okay. Now I'm just having fun with data. I'll be honest, I'm kind of a geek about this stuff. We can also compare monsoons by the number of lightning strikes that have been measured. And our friends down in the Phoenix and Tucson offices helped to gather this data. We're working our way from 1990 on the left. Each bar represents the number of lightning strikes across Arizona for that given year. And you'll see, even though precipitation were pretty well above normal as far as lightning strikes, just slightly above normal at this time in 2022. So we can track thunderstorms a number of different ways. Lightning is yet another we can use as well. Now, I've been asked, Brian, we've had 2 monsoons that have been pretty wet here, 2021, 2022. Are the monsoons getting wetter? And if you look at the trends over the past 70 years or so, indeed, there is a positive trend in the amount of moisture the Flagstaff area, and actually many locations in northern Arizona and the Southwest, are getting in the monsoons. And I won't get into it now, but this is a response to climate change, and kind of expected when you look at the science behind it. With our springs and late winters getting drier, it tends to engender wetter monsoons in general. So yes, we are seeing that trend at this time. So let's look at the primary flood events that we've seen so far this year. Over the pipeline east, or those drainages that flow to the east, we've had 14 flood events, of various scales. Pipeline west, you could say 4 or 5 events that came down Schultz Creek and impacted the Coconino Estates area. We're going to take a look at a couple of the primary events, one on each side. Okay, let's look at the July 14th event, 2020. This was the one that we showed the video of earlier. Okay, now the typical characteristics of flash flood producing storms are slow moving storms in an environment of copious moisture, those very moist, humid days that we feel. We can actually almost, feel the moisture in the air, to where we see repeated growth over and over the same area, which causes very heavy rain to just persist in the same location. The photo, which is the background here, is actually the thunderstorms developing before the heavy rains hit there on July 14th, 2022. And you see some very large towers, very vigorous thunderstorms growing over the San Francisco peaks, over the east side. And here's one of the details, which is characteristic of flash flood producing storms, is you see this main tower here in the middle. These towers on the right are actually growing too, and they're moving in this perspective toward the left, to also move into that same area which had heavy rain. There are more storms to the right of this that continued to move, in this case from south to north, over the area and caused the flash floods on that day. We're going to move right on to this image, which is kind of complicated, so I'm going to walk you through it. The colors you see here are the radar estimated rainfall on July 14th. So up here on the left, you can see radar estimates of upwards of 2.74 inches. In yellow here are the watersheds that denote the watersheds that flow off to the east, crossing Highway 89, which is the white line here, okay? The blue arrow denotes the flow of water down the government tank watershed, the watershed that was primarily impacted through this event, though the Peaceful Way, Copeland watersheds were also impacted as well. Recall that the burn intensity was very high up here in this area, high on the government tank watershed, high on the Peaceful Way watershed. This was actually above most of the rain gauges that were in place at this time. So the rain gauges didn't catch the rain that fell during this very large flash flood, except for this one lower on the government tank watershed that did record, I believe, just over an inch of rain during this event. But between 10 and 11 a.m., we had very heavy rainfall in this area from those clouds you saw in the earlier picture that moved over the area once, twice, and again dropping almost 2.7 inches in just 60 minutes. Very heavy rain. It was dry where the flooding would have the biggest impacts, here on Highway 89, here, in the Pioneer Valley area, coming down government tank wash. They didn't have any rain in this area. It all fell up on the mountain on those hydrophobic soils, caused all the ash and debris to come down the watershed at that time. So the heaviest rain was in place at about 10:21 in the morning. On that time, we issued our flash flood warning about 10 to 15 minutes later at about 10:30, 10:35. It took until 11:22 for the water to first overtop Highway 89. That's almost an hour later, moving at about 6 miles an hour. It's about what we would expect as it went down the 6 miles of the government tank watershed. The watershed flattens quite a bit at this point, so the water moves a lot slower at this time. It took another hour and a half, almost 2 hours, for the water to reach Neptune and Skeet down here in Pioneer Valley as it slowly seeped through this area, accumulating in a couple areas and then moving down into Pioneer Valley. I'm using as a base map here the modeled flood from J.E. Fuller and Associates, not the actual water that was observed in this case. Couple things I want to bring your attention to is the estimated rainfall rates up here. Now, these are estimated from the rainfall, and the radar estimated data was about an inch in 15 minutes, which we'd call about a 10-year event, or there's a 10% chance of it happening at any given point, all the way up to 2.7 inches in 60 minutes, which would be characterized as a 100-year event. Now, I get a lot of questions about, what we a 100-year event. What is a 100-year event? Why are we seeing so many of them in the area? For instance, that 2 inches in 30 minutes would be characterized as a 100-year event. So I have a question for you, and you can, write something in the chat if you'd like. How often would you expect a 100-year rainfall event to occur somewhere in the Flagstaff area? Once every 100 years? Once a decade? Maybe every year? What's the answer? What do you think? Well, let's talk about what the actual definition of a 100-year rainfall event is, because this always has a lot of confusion. A 100-year event is defined that at a specific location, the chance of that event happening in a given year is 1%. There's a 1% of that event happening in a specific location. And that's the key, is that this is defined over a specific location, over a specific rain gauge, for instance. Once you increase that area to a larger area, the chances of that event happening are much greater, okay? So we see 100-year rainfall events almost every active day somewhere in northern Arizona of the monsoon. A 100-year rainfall event, or these very high rainfall amounts, are happening somewhere. Now, we have a dozen or more excellent rain gauges that have been in place on the mountain for over a decade now. And I went back and looked through and saw how many 100-year events, or actually specifically how many times we've seen 2 inches of rain in 30 minutes over these 10 to 15 rain gauges. And indeed, it's happened 5 times in the past decade, okay? If you actually do the math there and look at the number of days sampled and everything, it turns out that that would work out to about a 30 to 50-year event for those specific criteria of 2 inches within 30 minutes. But it's a fascinating study. Actually, the National Weather Service is working on right now, re-evaluating what the rainfall frequencies are based on all of the gauge data that we have now up in the peaks, and the results are starting to be very interesting. So let's just add some perspective here. What you're looking at here is the rainfall estimates from July 14th over much of northern Arizona, and not just the zoomed in to the impacted and burned drainages. What I have circled here in this tiny little white circle are those extremely heavy 100-year event rainfall rates that I showed you that caused all the flooding on July 14th, caused that massive debris flow, is from that little bit of pink up there in this white circle. But what else happened on that day? Extremely heavy rain south of Belmont. Some massive rainfall amounts south of Cherry and Camp Verde, south of Jerome, west of Chino Valley, south of Ash Fork. Many areas in northern Arizona saw much more rain than what fell on the peaks that day that caused all the flooding. So here we have an example of probably half a dozen 100-year rainfall events happening in northern Arizona on just one day of our monsoon. All right, let's talk about August 7th, 2022. This was another big day in Flagstaff, this time on the west side of the peaks, to where we had the Schultz Creek watershed impacted by a storm that dropped 3/4 to an inch, maybe an inch and a quarter over the Schultz Creek watershed. You can't see it too well, but here in the you see some faint blue and green colors. These again are the radar estimated rainfall amounts superimposed over the map. The numbers here are the actual gauge amounts that Coconino County has put in. And we measured 0.92, 0.72, 0.71 in the Schultz Creek drainage, all within about an hour. These are not historic amounts. These are amounts, pretty routine monsoon amounts, but it fell on a very vulnerable drainage here. The heavy rain started at about 11:07 in this case, high on the watershed. Now keep in mind, the only area that was burned was the far northern part of the Schultz Creek watershed up here. But that was enough to start the water moving down the watershed. Now understand that this watershed had already seen several floods. Late July was very wet. July 27th, July 29th, both flooded over Highway 180, both flooded the Coconino Estates area in storms that were maybe even a little bit less rainfall than this one. But it took just over an hour for the water to work its way down Schultz Creek, actually to come down that fan. For those of you that have mountain biked in the area, down across the AZ trail, kind of parallel to the dog food trail, coming down those fans, meeting Schultz Creek, piling up in Schultz Creek, and then working its way down the Schultz Creek drainage, overtopping Eldon Lookout Road at 12:20, so about an hour later. From there, it took about another 40 minutes for it to go around through this, again, much more shallower area through that meadow, which is north of the Peaks Retirement Facility, working its way over, topping Highway 180 by 1 p.m., and then impacting the Coconino Estates area over the next couple hours. Here's a video that was taken just when the water moved across Mount Eldon Road. It actually broke into two at this point. One branch was close to the videographer here. The other one was actually much larger, is back to where that steam is. Much more water is actually moving across and toward Coconino Estates, soon to cross 180, about 30 minutes after that video was taken. All right, so let's just spend a couple minutes and talk about what does the future hold for the Flagstaff area fire scars. We're going to be dealing with the pipeline scar, with the museum scar for a while, just as we saw ourselves dealing with the impacts of the Schultz scar for a number of years. But every year, the flood threat will decrease. Okay, we will always see some measure of regrowth of vegetation. As more and more rain falls, the hydrophobic soils will become depleted. It will not react as rapidly. And as you know, there are some very aggressive flood mitigation projects in place that will also decrease the flood threat significantly. I mean, we've seen so much work happen so impressively fast on these watersheds. Most recently in the Schultz Creek watershed, which is going to change the nature of the flooding that we see. But we aren't going to return to normal anytime soon. And why is that? Well, the regrowth of the vegetation won't happen to appear as it was prior to the fire. We only have to look at Mount Eldon and the radio fire that happened, almost 50 years ago, and we still don't have trees on the mountain. The vegetation is going to regrow differently and very slowly over these watersheds. We're going to have some much finer growth, which is going to occur first with the small aspens, bushes, grasses, which is going to form first and hopefully stabilize the soils. But something that we've seen significantly is channelization of the mountain slopes. That is what used to be a rather even fanned out slope of the San Francisco peaks has now become very channelized and can efficiently move water from high on the slopes down to the lower slopes. And I have some pretty interesting pictures of that I'll show. But we can look at some impressive recovery of, let's say, the museum fire scar. This is after 3 years. We see a lot of grasses, some bushes have started to regrow. I took these photos just a couple weeks ago up in the museum fire scar. This shows that the soils are becoming very stable up there. Water is not running off nearly as fast. And as we've seen this year, the response from the museum fire has been muted, partially because of the recovery, which is continuing to happen there. But let's look at the east side of the peaks. I have a picture here that I took just 2 days ago of the east side of the peaks that shows some pretty severe channeling in the mid slopes of the San Francisco peaks. The white areas are showing these valleys, which are on the order of 20, 30 feet deep, which is helping to bring flow down the mountain much more efficiently than it used to. Well, how did this slope used to look? I was actually able to dig back through my archives back to 2014 and show what those slopes looked like then. Now the lighting is different here, so it doesn't show that channelization quite as dramatically, but you go back and forth between these two pictures and you can see just how much erosion has happened. And you understand that all of this debris, these rocks, what's composed these mountain slopes is now down in the alluvial fans. It's down in the flood areas that have impacted people's homes. It's dramatically been moved from high on the mountain down lower on the mountain. And these channels are we're going to be living with these for a long time because water can move, like I said, down these channels very efficiently. If you look at, I believe, Sugarloaf Mountain, as you're driving north on Highway 89, you can see just some extreme channelization and erosion of the slope there, which just allows the water just to very efficiently move right off the mountain. So what's the National Weather Service's job in all of this? Well, we work very closely with the county and the city in issuing warnings when we see those conditions, when the heavy rain is falling over these vulnerable areas, meeting those thresholds that we have in place. And those thresholds vary from storm to storm. If the soils are more saturated, it takes a lot less rainfall to cause flooding than if it's the first heavy rainfall of the season. But we'll be issuing our flash flood warnings when we see a particular area which is threatened. And these will warn on your mobile phone as an emergency alert if you live within or near the box or the polygon that we issue the warning for. This is different from the rave alerts that the county sends out. The rave alerts will go to all of those that have signed up for them who live in that area. So if you happen to be in Flagstaff and outside the polygon, you'll still get the rave alert if it's tagged by your phone or if it's your mobile phone that you have with you. But you won't get the National Weather Service warning because you're not within that polygon, okay? However, those that live, let's say, outside of Flagstaff and are just a tourist in the area, if they're driving through the polygon, the time the flash flood warning is issued, they will receive that warning on their phone because they're within or near that polygon. The National Weather Service also maintains a flood threat, a burn scar flood risk page on our website that evaluates the daily flood risk as we move on. So you can check out the National Weather Service webpage, weather.gov/Flagstaff during the monsoon season to check out the flood risk up to 3 days in advance. This is specifically for the Flagstaff area burn scars. It looks like time is about up, and I will just go ahead and close it with that and take any questions at this time. Thank you very much.
Thank you so much, Brian. We have a number of questions here. The first question is, are there maps located somewhere online where we can access them?
Maps, is that what you said? Yes, yes. Go to the Coconino County website. Just Google up Coconino County flood maps, and you'll see the very detailed maps that have been produced working with J.E. Fuller and Associates to show those flood threat areas. They've done a great job putting those together.
Awesome. And then we have another comment. I'm curious to take a closer look at the burn severity map and the map of the watersheds to see how my neighborhood may be affected. Where can we find those?
Probably one of the best maps that I've shown included the burn severity, the watersheds, and the modeled results from the modeling that was done. Those are also on the Coconino County website.
Okay, awesome. And then we have let's see, another question. Is there any reforestation being done, or we wait for the nature to do its job?
Boy, great question. Yes, yeah, you know what? I was just up on top of Mount Eldon about a month ago, and I'm seeing some reforestation being done up there. I'll be honest, I'm not familiar what plans there are throughout the entire pipeline scar and what the vision is for that, but at least up on top of Mount Eldon, I did see some evidence of that.
Awesome. And then we have another question. How does snowfall snowpack sit on top of hydrophobic soil? Any difference then any difference then on top of normal soil? Is the melt action any different?
Great question. There is not a great threat from snowpack on these slopes. While there might be a little bit more of a threat, perhaps, of some incipient avalanches early, really snow is a very steadying influence on the slopes. Snow melts slowly relative to the rainfall rates that might fall in the monsoon. And there's very little threat of any flooding in these drainages due to wintertime events. Of course, extreme weather can happen at any time with very warm wintertime storms, rain on snow events, but even in those, we're not going to see the rainfall rates that we typically would during a severe monsoon storm. So how well does snow sit on those burn slopes? I'll just say very well.
Awesome, thank you. And we have one last question. We frequently find impermeable layer. What is the major impact of lithology to occur flash flood?
Wow, I don't know. I'm not a soil scientist. I wish I knew more, but I'm not sure I could intelligently answer that question.
Awesome. Thank you for your honesty. One question in the chat asks, how did these fires start?
How did these, both of them were assumed to be caused by a human influence. At least the pipeline and the tunnel. The Haywire fire was likely lightning caused.
Interesting. That's awesome. If you have any more questions, please put those in the chat. I do have a reference shared about the maps that you are discussing, so I'll link those in the chat. But we also have a couple more questions. Are extreme rainfall events becoming more frequent with climate change?
Boy, that's a great question, and it's a very timely question. I showed a graph that showed that indeed the rainfall or the precipitation is increasing through our monsoon season. But very recently, I think it was 2021, some kind of cutting edge research has been done on storms with very high resolution rain gauge networks that seems to point toward, yes, storms are tending toward heavier rainfall rates. Now it's on a scale that might not quite be sensible, but it shows certainly that trend could be viable.
Well, I have a
Awesome.
question.
Right on ahead.
Yeah, I have a question for you. I moved to Flagstaff in 2019, and at that time, Lower Lake Mary and Mormon Lake had some water at least. And 2020, of course, dried up completely, nothing there. We've had 2021, we had some pretty heavy rains, and 2022 for sure, and I still see nothing there. What's going on?
We had a very dry year in 2020. 2019 was actually a pretty robust year. We had a lot of precipitation then. 2020, 21 sapped us of a lot of our moisture and standing water in the Flagstaff area. And it's tough to recover that. It's tough to recover that. You need the widespread moisture that you see in a good heavy winter to really recover that surface water.
Thank you.
You bet.
Interesting. I've always wondered that too.
Yeah.
I did see someone raise their hand. Jonah hit. Did you still want to ask your question? It was a really good question.
I see we also have one in the Q&A,
Q&A.
Jacqueline. Yeah.
Okay, we'll go to the next question. Do the floods help to alleviate the water shortage? Is the water collected?
Yeah, in a broad scale, yes. If we look at it as far as drought impacts or the level of the current drought, we've seen actually some relief of the drought conditions that we kind of entered into the monsoon because of the robust monsoon precipitation we've had. So it does alleviate some of the drought impacts. For instance, impacts to rangeland that could be quite dry if it was a dry monsoon are very green, growing very well this year. Stock ponds have been replenished across northern Arizona. We're seeing some relief in that way, but there's long-term drought, which we're still we can see all around us. Lake Mary isn't full. Lake Powell is an obvious example. That there's a long ways to go to recover all of the water and come completely out of this drought.
Awesome. Next question is, where can we find maps that give mile markers on the roads?
Oh, good question. I don't have that with me, but I certainly could provide a link to get that for you. ADOT might be a good starting point, but I could certainly make that available.
Great. And I think we have 2 more questions. How long does it typically take for a burn scar to recover?
Boy, that's a hard question to answer because it recovers very iteratively. And it depends where the burn scar is. Let's talk about the Flagstaff area. The photos that I showed you of the museum scar, that is after 3 years, we see some good grasses, some young aspens starting to grow, the soil really starting to stabilize. We're seeing the response or the flood response is being decreased significantly after only 3 years. But still we have the channelized flow. So I would say on the order of, let's say 4 to 7 years, you'll see significant recovery, significant decrease in the flood threat. But in some areas, and depending how much moisture falls, how much vegetation can come back, if there's mitigation which is done, there can be significant progress in just a couple years.
Great. That always crosses my mind too whenever I look at the burn scars.
Yeah.
And the last question is, what is the biggest monsoon storm, greatest rainfall you've ever seen?
Wow. What immediately comes to mind is July of 2018 on the east side of the peaks, where we saw a very large area of 4 to almost 6 inches of rainfall that fell in just over 2 hours. It truly was an incredible amount of rain, which kind of bear witness to the recovery of the Schultz scar and the mitigations that were in place, that did not cause massive amounts of damage downstream, because it happened right over the Schultz burn scar, which it happened 8 years before that. But these drainages had been mitigated. The area had recovered over 8 years. And while there was significant flooding, it was nothing like it would have been had that rain fallen this year, where it would have been by far the biggest storm we would have seen. But seeing 6 inches of rain fall in just over 2 hours, yeah, it's mind-boggling. That's something we would call like a 500 to 1,000 year storm.
Awesome. We do have a question related to that. We could probably get to it really quick. We've frequently found extreme rainfall in South Asia. What is major cause to change the precipitation pattern, like Pakistan and Bangladesh 2022 flash flood?
Boy, I'll be honest, I don't know. I'm not familiar with the perhaps the weather events that were referred to in the question. So sorry.
Well, Brian, I want to say thank you so much for joining us and giving this fascinating talk. You answered a lot of my questions about what's going on with the crazy weather around here and what causes all the flooding that we've been seeing. Thanks to you. Thank you to our sponsors and to everyone who's helped out with the festival. I'm going to put a link to our survey in the chat. If folks would like to get to that and go to the survey, we really appreciate it. It helps us make the festival better for everyone. And I hope you have a wonderful evening and you join us for the rest of the, what are we now at? 7 days, the best 7 days of the year. Thank you so much. I'll give you a second to get to the link to the survey.
All right. Thank you, everybody, for joining today. And we are having an open house at the National Weather Service on Saturday. So stop on by on Saturday out in Belmont. We'd love to see you.
Brian, is that something people need to register for?
Nope.
Nope. Just show up.
Just show on up. Yep. We'll be doing a balloon launch at noon and at 4 p.m. People want to watch that or just come anytime between 11 and 4.
Thanks so much. That's great information. All right. Thank you very much, everyone. Have a great evening.
Thank you. Bye-bye.
Thank you.
Bye.